A request to get a start on the question, as you can see on the screen. A river is flowing downstream at a rate of 2 meters per second. Brendan, who has an average swimming speed of 3 meters per second, decides to go for a swim, goes into the river, swims downstream to a certain point, then swims back upstream to the starting point. Total time 4 minutes. How far did he swim downstream? Well, the thing you need to understand or remember or realise for this question is swims downstream to a certain point and then swims back to the starting point. So what that means is Brendan swam, let's say that's your starting point. So Brendan swam a certain distance, so that's downstream, and then he swam back to the starting point. So the distance that he swam down and then back are the same in each direction. So what we then need to decide is, we obviously realise that if he's swimming downstream, he's swimming with the current. So therefore the current is assisting him. So if he can swim at 3 meters per second, so the speed downstream is equal to the speed he can swim plus the current, because the current's going to help him, which is 5 meters per second. And then upstream is going to be the speed he can swim minus the current, because the current's trying to slow him down. So 1 meter per second. Okay, so we've got some of that information there. Now, what we're going to assume, so the assumption, is that he swims at a constant speed. So there is no acceleration. Okay, no acceleration. Therefore, the formula that we're going to use is speed equals distance over time. Okay, now the thing is, what we know is that the time it takes for him to swim downstream, okay, plus the time it takes for him to swim upstream has to equal 4 minutes. Now, that's equal to 240 seconds. We have to change it into seconds because meters per second, meters per second. Okay, so we need to make sure that's in seconds for a start. Okay, so there's our first equation. Woohoo! Equation number 1. Okay, and then what we say, all right, well, I'm going to use this formula now. Okay, but what do I know? Well, I know the distance in one direction has to equal the distance in the other direction. So therefore the distance down has to equal the distance up. Alright, so the distance down is going to be the speed downstream multiplied by the time it takes to go downstream. And the speed will be the upstream will be the speed upstream multiplied by the time it takes to go upstream. And I think, if you think about those, that is your second equation. And I'm going to stop there and let you have a think for the rest.